Good morning, my dear children. Once again, I'm here with the content. There are some of the types of the sets, some more types of the sets, and the sums based on these types of sets from the exercises. So, the first one is here the finite sets. A set which is possible to express the number of elements is known as finite set. Example, set of letters in English alphabet. So we can represent all these letters in English alphabet into a set. So it is a finite set. Means where we can write the starting to the ending. So which is a finite set. Example 2. Set of prime numbers smaller than 90. So we can start from 2 and we can end it with the smaller less than 90, all the prime numbers we can end. So where here in both the examples we know that the starting and ending of the numbers of the set. So that is why these two are called as finite sets. Now infinite sets. Sets which are not finite are known as infinite sets. Example, set of natural numbers. So when you write this into a set, we can write the starting number, we cannot write the ending number. So that is why it is a infinite set. Now, set of lines parallel to x-axis. We have many lines, infinite lines, which are parallel to x-axis. So this is also an infinite set. The next, another type of sets are equal sets. What are equal sets? Two sets A and B are said to be equal. The cardinal number and the elements of both the sets are also same. Then we say that both the sets are equal. Example, set A is equal to 1, 2, 3 and set B is equal to 2, 1, 3. Here the cardinal number, that is n of A, is equal to 3 number of elements, that is 3. And in B set, the cardinal number, that is n of B, is also equal to 3. So number of elements in both the sets are same, as well as the elements are also same. But the elements are not in proper order in the set B, but same elements are there in both the sets. That's why A and B are called as equal sets. Next one, another second example, X such that X is a letter in the word assassination, set B is equal to X such that X is a letter in the word station. So let us write both of these set builder forms into a roster form. That is set A is equal to letters, all the letters in assassination word, you write it, leaving the repeated letters. So A, S, I, N, T, O, set A, and set B is equal to S, T, A, I, O, N. So again, in both the sets, A, the number of elements are also same, as well as the elements are also same. So A and B are equal sets. Now, equivalent sets. Two sets A and B are said to be equivalent if the cardinal number of the sets is same but not the elements. Example, set A is equal to 1, 2, 3 and set B is equal to 5, 6, 7. Here, n of A, the cardinal number of set A is 3 and n of B, the cardinal number of set B is also equal to 3. But the elements are different. So that's why here A and B are called as equivalent sets. Now, sums from exercise 2.3. Check whether the following sets are equal or equivalent. Give reasons. First question, A is equal to X such that X is a letter in the word follow. B is equal to X such that X is a letter in the word flow. C is equal to X such that X is a letter in the word wolf. So let us write all these set builder forms into a roster form. So A is equal to F, O, L, W and set B is equal to F, L, O, W and set C is equal to W, O, L and F. Here, in all the sets, the cardinal number, that means the number of elements are same. That is, 4 elements are there in all the 3 sets. So the cardinal number is same, as well as the elements are also same. So these 3 sets are equal sets. That's why A is equal to B is equal to C. Second one, A is equal to X such that X is a multiple of 10. B is equal to 10, 15, 20, 25, 30, etc. So let us write set A into a roster form. So set A is equal to 10 multiples of 10. That is 10, 20, 30, 40, 50, etc. B is equal to 10, 15, 20, 25, 30, etc. Here A and B are not equal sets because set A consists of multiples of 10 and set B consists of multiples of 5. The elements are not same, so they are not equal sets, or as well as they are not even equivalent sets also, because there is no proper number, particular number, there is no ending number in the set. So we cannot say that whether the number of elements in both the sets are same or not. Now, third question, m is equal to 1, 3, 5, 7, 9. Set n is equal to x such that x is an even number less than 12. So m is equal to 1, 3, 5, 7, 9, and n is equal, write it in set roasted form, 2, 4, 6, 8, 10. Elements, even numbers which are less than 10. Here, the cardinal number of m and n is same. Both the sets have 5 elements, but the elements are different. So we can say that m and n are equivalent sets. Now, some more sums from exercise 2.4 based on the second concept, that is finite and infinite sets. First one, state whether the following sets are empty or not. The set of lines passing through a point. You know that many lines can be drawn through a point. So it is not an empty set. We have some lines which are passing through a point. So that's why it's not an empty set. Second one, set of odd natural numbers divisible by 2. You know that any odd number never be divisible by 2. So it is an empty set. Now, second question, state whether the following are finite or infinite sets. First question, set of months in a year. We know that the starting month and the ending month of the year, so it is a finite set. Set of numbers which are multiples of 5, which is in an infinite set. Why? Because we know the starting number, which is 5. Where is the ending of this number? Multiples of 5 means we can write infinite multiples of 5. So that's why it's an infinite set. Now, third question, L is equal to, set L is equal to 0, 1, 2, 3, 4, etc. You know, etc. means what? There is no ending number in the set. So it's a infinite set. Now set k is equal to 11, 22, 33, 44, 55. So you know the starting number and you know the ending number in the set. So that's why it is a finite set. So these are the sum of the sums from the exercise 2.3 and 2.4 based on equal and equivalent sets, finite and infinite sets. Now let us learn that you don't have this in your textbook, but beyond your textbook, this is the additional information which I am giving to you. So please learn it. This will help you in further classes. So set A, basic operations on more than 2 sets. So let us take for the 3 sets, set A is equal to 1, 2, 3, 4, 5, set B is equal to 3, 4, 5, 6, and set C is equal to 6, 7, 8. So let us find A union B intersection C and A union B intersection A union C. So here A union B intersection C. First, let us find B intersection C. You know that B intersection C means the common elements of both the sets. So here the common elements of both the sets is 6. So B intersection C is equal to 6. Now, A union B intersection C is equal to 1, 2, 3, 4, 5 A set union the intersection of B and C, that is 6. So when you join all these elements, union means you know that you have to write all the elements. So 1, 2, 3, 4, 5, 6 is the solution for A union B intersection C. Now RHS part. What is RHS part? A union B intersection A union C. First take A union B. A set consisting of 1, 2, 3, 4, 5. B set is 3, 4, 5, 6. The union of both the sets is 1, 2, 3, 4, 5, 6. Now A set A union C. A set is equal to 1, 2, 3, 4, 5. Union C set is 6, 7, 8. So A union B into A union C is equal to all the elements of both the sets, is 1, 2, 3, 4, 5, 6, 7, and 8. Now A union B intersection A union C. The common elements in both the sets, that is 1, 2, 3, 4, 5, and 6. If you observe it, in LHS also we got the same answer 1, 2, 3, 4, 5, 6. And even in RHS also we got the same answer 1, 2, 3, 4, 5, 6. So we can conclude that A union B intersection C is equal to A union B intersection A union C. This is De Morgan's law. We have so many are there in the same model. So you can do this all in further in next higher classes. So I will give you based on this in assignment also, so that you will have a practice on this also. So next one is through Venn diagrams also we can express the same thing. See here, the first one is A set. The second figure is representing B intersection C. The common part of B and C is shaded here. Now the third figure is representing A union B intersection C. That means A set is completely shaded and B intersection C portion is only shaded. So this is representing A union B intersection C. Now see the second part of this figures and diagram. A union B. So A and B are completely shaded in this. Now second figure you see A and C are completely shaded in this second figure. Now in third figure, A is completely shaded and the common part of B and C is shaded. So A union B intersection A union C is a third figure, which is representing when you observe both the third figures, both are same. So we can say that we can conclude that A union B intersection C is equal to A union B intersection A union C. So children, with this we come to an end of this chapter, that is sets. So you practice once again all the concepts what you have learned in this particular chapter, and which is very very important for the objectives. So the next two sessions you are going to have two revisions. Then you will have an objective test based on this chapter 2. Then we will be starting the new chapter, that is polynomials. You see here in this thank you also we have two bunches which are full of with different balls of two sets I have mentioned there. The two sets, that is the which are of different color balls. So children, don't forget all these concepts what you have learned in chapter 2, that is sets chapter, and learn the concepts very well. And today's content also is very very important. Thank you one and all.